Imagine boarding a spaceship, climbing into a sleek pod and closing your eyes, only to wake up decades or even centuries later at a new world. No food shortages, no cabin fever, no wasting away in zero gravity. This is the promise of cryosleep and stasis pods, a concept once reserved for science fiction, now edging closer to reality. But is it really possible to sleep through the stars? Or is this just a futuristic dream? Cryosleep, also known as suspended animation, is the idea of slowing down or even pausing biological processes so humans can survive long-duration space travel. Unlike freezing a body in ice, true cryosleep would carefully reduce metabolism, body temperature, and cellular activity, keeping the traveler alive but in a near hibernation state. Science fiction movies like Alien and Interstellar popularized the idea, but modern research is exploring whether hibernation, like states seen in animals, could be applied to humans. The distances in space are almost unimaginable. Even at current rocket speeds, reaching Mars takes around 6 to 9 months. A trip to Proxima Centauri, the nearest star, would take over 4,000 years. Without cryosleep, astronauts will face enormous challenges. Food and water storage for decades, muscle and bone loss from microgravity radiation exposure, psychological strain of being awake in a confined space for years. Cryosleep could cut these risks by reducing resource use, protecting health, and making deep space missions more practical. Researchers are studying therapeutic hypothermia, already used in medicine to slow metabolism during surgeries. Hibernation triggers some animals like bears and ground squirrels, naturally lower their body functions for months. Scientists are investigating whether similar pathways exist in humans. Stasis pods, futuristic capsules designed to monitor vitals, deliver nutrients, and maintain the body in a safe low-energy state. NASA and private companies are actively exploring how these technologies could work together for long-duration missions, but the hurdles are huge. Safely lowering metabolism without organ damage, preventing blood clots, infections, and muscle decay, ensuring the mind wakes up intact after years or decades of stasis. Ethical questions: would cryosleep passengers age differently? What about consent for trips lasting generations? For now, cryosleep is experimental. The longest stasis-like state achieved in medicine lasts only weeks, not centuries. Still, the potential is too powerful to ignore. Imagine colonization missions where settlers wake up on new planets, ready to build generational ships, replaced by single crew journeys lasting centuries. Even long-term medical uses on Earth, from trauma care to critical surgeries, cryosleep could be the key to making humanity a true interstellar species. So the next time you see a sci-fi movie where travelers drift across the stars in glowing pods, remember it might not be fiction forever. Cryosleep and stasis pods could one day be the doorway to humanity's future among the stars. Would you climb into a stasis pod and wake up on another planet centuries from now? Let me know in the comments. And don't forget to like and subscribe for more journeys into the future of space exploration.